वही मम्मी की रखी है। Hello, Shant. Hello, Shant. Am I audible?
Hello, sir. Good evening, sir.
Good evening.
Yes, sir.
So we were doing question answers from equations of motion, right?
Yes, sir.
So the kinetic equations of motion that we were doing, we have to
Yes,
do
sir.
questions from that only, right? And we had started with a few questions which started like the equations of motion where they are applicable directly. Like you can say V equals to U plus AT. Then we started with
About differentiation, sir.
which equations?
Sir. Differentiation, sir. Differentiation.
Okay, differential equations. Yeah, we were doing about the instantaneous velocity.
Yes, sir.
Like we did instantaneous velocity and instantaneous acceleration also will do. And
Yes,
then we
sir.
can continue with the questions that you sent out. Right? So from your book, we'll be doing those questions.
Yes, sir.
Okay, just 1 minute. I'm sharing the screen. So we had seen that the instantaneous velocity is given by V equals. Suppose I want to find out the instantaneous velocity. So instantaneous velocity at any point of time is given as V equals to dx by dt. Right? If we represent the position by x, so it is given by dx by dt. Or we can also write velocity to be equal to bs by dt, which represents the rate of change of displacement with respect to time. Both of them, they are equivalent. Either you can use position with respect to time, or you can also use displacement with respect to time. Both are equivalent for the terms velocity. So
Yes.
for the velocity at the beginning of an event, that is the initial velocity, and the velocity at the ending of an event is the final velocity.
Yes, sir.
So here we'll observe a few things and then we'll try to identify initial and final velocities. Then the acceleration. Now we'll be discussing the instantaneous acceleration. So instantaneous acceleration is given by instantaneous acceleration A is given by dv by dt. That means the rate of change of velocity with respect to time. So I
Yes,
can
sir.
obtain velocity acceleration as change of velocity with respect to time. So instantaneous acceleration will be given by dv by dt. If you want to find out the average acceleration, so average acceleration is given by v minus u over t. So change of velocity by time, that is given as average acceleration. Now, for most of the cases for your studies, we will be including only uniform acceleration. And we know if acceleration is uniform, so for uniform acceleration, instantaneous acceleration and average acceleration will be the same. They will be equal.
Yes, sir.
Right? Uniform acceleration means the acceleration is not changing. So when the acceleration doesn't change, obviously the instantaneous value of the acceleration and the average value of acceleration, both of them, they will be equal to each other.
Yes, sir.
But
Same.
yeah, they will be the same. So where all we observe the
Okay.
instant these values of
Sir,
acceleration, generally in the case
sir,
of gravity. So for the gravity, yes,
sir, can you give a definition of this, sir?
definition of what? Acceleration.
No, sir. Instantaneous acceleration.
Instantaneous acceleration. Okay.
Yes, sir.
Yes, sir. the acceleration at a given instant of time. So the acceleration at a given instant of time is called instantaneous acceleration. So the acceleration of an object at a given instant of time,
Yes, sir.
at a particular time, that we call as the instantaneous acceleration. Then we have the average acceleration. Acceleration for the entire journey will be the average acceleration. Got it? So we observe here for the case of gravity, and then we will obtain the equations of motion. So let's see. Consider here an object falling vertically downward. So suppose if you have any object which is falling downward here. So when the object falls downward at the highest point when it was in our hands, here we obtain that its initial velocity is equal to 0. At the time, let us take at this time to be t equals to 0. So at time t equals to 0, the velocity of the object is 0. Got it?
Yes, sir.
Now as it is released, it starts traveling downward. Okay. So when it travels downward, what is the acceleration at any given instant of time?
Sir, plus G, sir.
How much?
Plus G, sir.
Yeah, acceleration at any given instant of time. So if it is at this point, whether it is at this point, at any point, the acceleration acting on this is equal to g.
Yes, sir. Positive
And it
G.
is, yeah,
Yes.
and it is also acting vertically downward. G is
Yes.
also acting downward, and its
Yes.
direction of motion is also downward.
Yes, sir.
Okay. So value of g is generally taken as 9.8 meter per second square, and if anywhere stated, we take it as 10 meter per second square also.
Yes, sir.
Now the moment when the ball strikes the ground, so that velocity with which it strikes the ground, we call that velocity to be the final velocity. Okay. So this is our final velocity v with which it strikes the ground. Now this is an example of uniformly accelerated motion, as acceleration is constant throughout the journey.
Yes, sir. Constant.
Yeah. So acceleration is constant throughout the journey, and hence it is an example of uniformly accelerated motion.
Okay.
Now we will obtain the equations of motion. I told you that we'll be deriving the equations of motion from the different formulas. Also, I'll be telling you few formulas for differentiation which we studied. Today, I'll also tell you some formulas of integration. See,
Yes, sir. Yes.
integration means just for the differentiation. If you understand, in the previous part of the differentiation, we did something. I told you some formulas of differentiation.
Yes,
Okay.
sir. Yeah.
So let us try to understand both the things, differentiation and integration. So consider here, we have a graph between, we have a graph for the, let's say I have a variable y and here I have a variable x. And suppose I have a graph something like this. Okay, let's say a graph is like this. So from this graph, as I can see that graph is not a linear graph. Is this a linear graph?
Yes, sir.
Is this graph a straight line?
No, sir.
No. The graph is not a straight line and hence
Yes.
it is not a linear graph. Right? The graph is not a linear. It's not a straight line. Okay. So for such equations, if I want to determine the slope of the tangent, so as we know that tangent is a line which touches the curve at just one point. So I will try to draw the tangent at different points on this. Okay. So we'll try. I'll draw a tangent at this point. I will try to draw a tangent at this point. I'll also draw a tangent at this point. A tangent here. A tangent here. A tangent. So at all these points, I'll be drawing out tangents. So let us see how will the tangent look like. So at this point, if I draw a tangent, so tangent will be touching this graph at just one point. And it should be something like this. Am I correct? For the second one, again, it should be something like this. It should be touching the graph at just one point. So like this. For this point, if I drop the tangent, so it will be like this. For this point, the tangent will be like this. And for this point, I'll be getting the tangent like this. Okay. Assume I have taken this as a y and x. Assume that if this is a displacement time graph, suppose here it's not x, it's time. So had it been a displacement time graph, so can I call it as a uniform motion or a non-uniform motion? What type of motion do I observe here?
Sir, it's a non-uniform motion.
Yeah, it is a non-uniform motion. So this
Yes, sir.
type of motion, it is a non-uniform motion, and therefore the object is having variable velocity. It's
Yes,
having
sir.
different velocity at different points of time. Now, if I
Yes,
want to find out the instantaneous velocity at any given instant of time, suppose I want to find out the instantaneous velocity at this time t1. I also want to find out the instantaneous velocity at this time t2. I also want to find out the instantaneous velocity at this time. Okay, so at these different times, let this be your time t1, let this be time t2, let this be time t3. So I want to find out the instantaneous velocities at all these points. Look, if I want the average velocity, so my average velocity will be given as total displacement by total time,
yes, sir.
right? But the
Yes,
instantaneous velocity, that is, I want what is the velocity at this point of time? What is the velocity at this point of time? At each instant of time, the velocity is different. And it is given, the instantaneous velocity is given as slope of the graph. Okay. So if you have the slope of position time graph, slope of xt graph or position time graph, it gives us the velocity. Got it? So just changing the
yes,
variable here, it was y, I'm making it x, so that now we can easily recognize that it is a position time graph, and in a position time graph, the slope of the graph represents the velocity, right?
yes, sir.
So if I want to find out the instantaneous velocity, I will be finding the slope of this tangent at t1. If I want the velocity at t2, I will be finding out the slope of the tangent t2. If I want the velocity at time t3, I will be finding the slope of this tangent at t3. Got it? So whenever
Yes,
I am finding the instantaneous velocity, I am finding the slopes of these tangents which are given by which is given by v equals to dx by dt. So you have to remember it both ways. If you are finding the slope, you are finding dx by dt. If you are finding dx by dt, you are finding the slope of the tangent. Okay. So here, if you observe the slopes of these tangents, so if you compare the slope of the tangent at t1 and t2, okay. So which tangent has a greater slope?
sir. T3, sir.
No, I'm observing only t1 and t2. So which one is having a greater slope?
T2, sir.
T2. Slope
Yes, sir.
means the tilt. Okay.
Sir? Yes,
So the tilt or the slope is maximum at this point t2.
yes.
What about the point t3? If I compare t1, t2, and t3, which one has the greatest slope?
T3.
T3. No. T2 has the greatest slope. See, by slope, what do I mean? When I say slope of a graph, So slope of a graph means something like this. Okay. Consider here three graphs. Here
Yes.
A, B, and C. So these are the three graphs which I have made. Now the inclination of graph A to the x-axis, inclination of graph B to the x-axis, and inclination of graph C to the x-axis. So which one has the greater inclination?
Sir, C, sir.
Graph C? Yes, C has a greater inclination. So C has the maximum slope.
Yes, sir.
Okay, so now if I observe the tangents, see the tangent at this point T1, it is a little bit sleeping. The tangent at the point T2, it is making a greater angle. But the tangent at the point T3, it is almost flat.
Yes,
Whereas at this point, it's actually flat.
yes,
Got it?
sir. Yes,
So
sir.
when the tangent becomes flat, it represents zero velocity. It means
Uh,
that the slope is zero.
sir, so here we have to see tangent, sir.
Yeah, you have to see the tangent
Okay,
and
sir.
its slope. Got it?
Yes, sir.
Okay. So that was the reason why I explained you this graph. So from the graph, the region where you observe the maximum slope, that will be the maximum velocity. Okay.
Yes, sir.
For
Got it.
example, if I observe this region, see, if I observe the region BC, so here I observe that the graph is moving downward. And if I find the slope during this time, so I will be getting a negative slope. It will be
Oh,
something that like this. I will be getting a negative slope here in the region BC.
yes, sir.
Okay. So during the region BC, the vehicle is having a negative. Okay. Again, it increases. So at this point, again the tangent is becoming almost vertical. So here also the velocity is maximum.
Yes, sir.
So the same thing we can infer from the velocity time graph also. In the same way, if you have a velocity time graph, so then also you can infer the same things. Got it?
Yes, sir.
So what we will obtain from the velocity time graph?
Sir, total distance by time, sir.
Okay. So again, suppose the same graph I obtained. Let us say now I have again a graph, but this graph is now the velocity time graph. Okay. And again, the graph is something like this. Again, the graph is increasing, then it's like this, and then again the shape of the graph is same. So what do I get from this? Again, if I draw the tangents at different points, let's say I draw a tangent at this point, I draw a tangent at this point, I draw a tangent at this point. So what do I get? By finding the slope of the tangent, what do I obtain from the velocity time graph?
Sir, we'll get slope, sir.
Yeah. So
Yes,
if I find a slope of velocity time graph, so the slope of the velocity time graph, this gives me the acceleration. Got it? Now
oh,
here, if I find the slope of the tangent, I'll be getting the quantity acceleration. So I can say that at this point, the graph has a higher acceleration. At this point, it has a low acceleration.
yes,
Okay. Now it's velocity time. That means the graph is representing the change of velocity with time. Got it? So here
yes,
from this graph, I can obtain acceleration will be equal to dv by dt. Okay. Now, this was about differentiation, and we had seen different formulas of differentiation. Like we had seen the formula of differentiation to be this one. We had seen the formula of differentiation as like we had seen d by dx of a constant. Any constant is zero. We had seen the differentiation d by dx of x to the power n is written as n x to the power n minus 1.
yes, sir.
And I told you that d by dx of log x is equal to 1 by x, right?
Yes, sir.
If you remember, I had also told you the differentiation of sine x, d by dx of sine x is cos x,
Yes, sir.
and d by dx of cos x is minus sine x.
Yes, sir.
Yeah,
And
yeah. So
yes.
these were the formulas of differentiation. A few other formulas are also there, but whatever we require, we'll be telling.
Okay.
On this basis, you can perform a few questions. For example, suppose I have given y equals to, let's say, x cube plus x squared plus 3x plus 7. So can you find the value of dy by dx from this?
Yes, sir.
Okay, so find it out.
Okay.
Find the value of differentiation dy by dx. Okay, so did you get the answer, Ishan?
I'm doing, sir.
Okay.
Sir, I'm getting wrong, sir.
Okay, what's the answer you are getting?
Sir, I'm getting 2, sir.
2. Okay. See, how do we find it out? Initially, it's written as y equals to x cube plus x squared plus 3x plus 7. So on both the sides, I apply the operator d by dx. So here also I write d by dx. On this side also I write d by dx. So here I have the y, so I write y. And here I have d by dx of x cube plus x squared plus 3x plus 7, right?
Yes, sir.
So since differentiation can distribute over addition, so I will be able to write it with distribution. So I'll be writing it d by dx of x cube plus d by dx of x squared plus d by dx of 3x plus d by dx of 7. Got it?
Yes, sir.
Okay. Now see individual one. So which apply the formula over here. Which formula is applicable in this part?
Sir, dy by dx x power cube, sir. X cube.
Okay. Okay.
Sir, a into d power x power n by dx.
Okay. So I'll be writing is 3 times of x to the power 3 minus 1. Is it correct with the formula? Just check.
Yes,
D by
sir.
dx x to the power n is nx to the power n minus 1. Got it?
Yes, yes, sir.
In the same way, here also I'll be writing 2 in the front. So I'll get 2 multiplied with x to the power 2 minus 1. Okay. Here 3 is constant. So I'll be putting this 3 outside and I will get here dx by dx. Okay. And here I have d by dx of 7. So since 7 is a constant number, so this differentiation should be equal to 0.
Yes, sir. 0.
Okay, so the last one has to be equal to 0. And here we get 3x squared plus 2x, got it?
Yes,
Plus
sir.
we have here, either you apply the formula for this or you can assume this dx and dx cancel each other.
Yes, sir. 3, sir.
Okay, even if you assume dx and dx cancel each other, so you get here plus 3
Yes.
plus 0.
Yes, sir.
So our answer is 3x squared plus 2x plus 3. Got it? This is my dy by dx.
Okay, sir.
Try this one and try to find out again. So I have y equals to,
Sir, can you keep that one, sir? I'm writing.
okay,
Done, sir.
okay.
Yes.
Let's see another question and I hope you will try to do it. Okay?
Yes, sir.
So this is minus of 2x squared plus 4x minus 1. Solve this out and obtain dy by dx.
Okay, sir.
Okay, Shan, have you obtained?
I'm doing, sir.
Okay. So if you check your answer, you would have got here dy by dx equals minus 4x plus 4. Yeah, Ishan, did you get this?
Sir, I
Ishan,
got, yes, sir. Sir, I got uh, plus 4x plus 4, sir.
how could you get plus 4? See, there
Wait,
is a
sir.
minus sign. Did you consider this minus sign?
Oh, oh, yes, sir.
So if you consider the minus sign, you will be getting a minus here.
Oh, yes, sir. Yes.
So is this what you got?
Yes, sir.
Minus 4x plus 4.
Yes, sir.
Okay. So let's try to do a few more questions. Try this one also. We are given y equals to 4 under root x. Try out this.
Sir,
Find dy by dx.
that's it, sir. 4 root
Yeah.
x. That's it, sir.
Okay. So what did you get here? See, this x can be written as, I can write this as d by dx of, I'll be writing it as d by dx of 4,
Yes.
and root x can be written as x to the power 1 by 2, right?
Yes, sir.
Okay. So now can you differentiate?
Yes, sir.
Okay. So it will be 4 multiplied with 1 by 2 multiplied with x to the power 1 by 2 minus 1.
Sir, how -1, sir?
The formula, the identity that we were using,
Ah, yes, sir.
d by dx of x to the power n.
Yes, sir. By
Yeah,
dx. Yes.
yeah. So d by dx x to the power n is equal to n x to the power n minus 1. So just by using this identity, we obtain here power n minus 1. Got it?
Yes, sir.
So now this will be equal to, I can cancel this 2 and 4. So I will be
Yes.
getting 2 x to the
2.
power minus 1 by 2.
Ah, yes, sir.
X to the power minus 1 by 2 means I will be getting 2 divided by x to the power 1 by 2. And x to the power 1 by 2 means square root of x. So I'll be able to write it 2 over square root x.
Yes, sir. 2 by root x, sir.
2 by root x.
Yes.
Got it?
Yes, sir.
Okay, now let's try to evaluate this one. Suppose the position of a particle x is given like this. It's given 2t squared minus 4t plus 1. Okay. So this is how the position of a particle is described with respect to time, where x is in meter and t is in seconds.
Yes, sir.
So can you find the, uh, the expression for velocity of the particle? Okay, shall I solve this?
Yes, sir.
Okay. So see, I want the velocity of the particle, and I know here, let's say x is given in, x is the position and t is time. So x is position in meter and t is time in second.
Yes, sir.
So if I want the velocity, I know that velocity is given by dx by dt.
Oh, yes, sir.
Okay. So
Yes.
definitely, if I differentiate, if I apply d by dt on both the sides, so on left hand side also I apply here d by dt on the right side. So I have d by dt of x, and on the left hand side also I write here d by dt of this whole expression, which is 2t squared minus 4t plus 1. Got it?
Yes, sir. Yes.
So I know that dx by dt will be velocity. So I can write dx by dt to be equal to v. And here I will be getting d by dt of
2t square,
t
sir.
squared
Yes,
plus
yes, sir. D
d
by
by
dt
dt of minus
minus 1.
4t.
Yes, sir. Plus d by dt of plus 1.
Yeah. So d by
Yes.
dt of plus 1. Now,
Sir, that's
yeah,
0,
hmm?
right, sir? D by
Yeah,
dt.
yeah, this last one will
Yes,
be
yes.
0.
Yes, sir.
And what will be the value of this first one?
Sir, sir, it's d by dt to t square. So, sir,
So 2
a
will be
into
taken. Okay, this 2 is
yes,
outside. You can apply d by dt of t squared.
yes, sir.
So what do you get? Okay, let's do it step by step. I've written 2 and then I get d by dt of t to the power 2
T square.
t square. Got it?
Yes, sir.
And here I take minus 4
Yes,
as
sir.
common and I get d by dt of t.
Yeah.
Okay, and this one is
Yes,
0.
sir. Sir, here dt cancel, right, sir?
Cancel. Okay, so they cancel, they make it 1.
Yes, sir.
And here if
No,
I
sir.
apply the formula, so I'll be getting 2 multiply 2
Yes, sir.
multiply t to the power 1. Right?
Yes, sir.
And here I get minus 4 plus 0, so I can leave.
Sir,
So I get, yes.
uh, yes,
So,
sir. Continue.
so I got the formula of velocity v as 4t minus 4.
Sir, your voice is breaking, sir. Hello,
Yeah,
sir.
what happened?
Sir,
Yes.
your voice is breaking, sir.
Okay,
Sir,
just
your
let me.
voice is breaking, sir.
Okay, just 1 minute. Let me
Oh,
just change my network.
yes.
Just give me 1.
Yes, sir.
I hope it's okay now.
Yes, sir. Now it's okay.
Okay. So this is now the formula for velocity. So can you find the velocity at t equals to 0 second?
Yes, sir.
Okay, so what will be the answer?
Sir, t equal to 0 minus 4, sir.
Minus 4. The
Yeah,
velocity at t equals to 1 second?
t equal to 1, 0, sir.
0. The velocity at
0,
t equals to 2 second? T
2 seconds.
equals
Yes,
to
sir.
2 second.
Uh, 4, sir.
So can I say that I am finding
Sir, what,
instantaneous
sir?
velocity? See, I am finding out the velocity at every, right?
What, sir?
So whenever we need to find out instantaneous velocity, at that point of differentiating, obtaining the formula for velocity, and then obtain instantaneous velocity at every instant of time.
Yes, sir.
Got it?
Yes, sir.
So, okay. So now I think you can solve out some similar questions.
Oh, yes, sir.
Okay. So suppose your position x is given as 1 plus 3t squared minus 4t cube. So you need to find, let me give you some of the questions here and let's try to find them out. So, so you need to find the position at t equals to 0 second and t equals to 4 second. Then you need to find the average velocity during 4 seconds. Then you need to find instant velocity at t equals to 3 seconds, and velocity at t equals to 4 seconds. So the next one. Okay, Ishant, how many of these can you find out? Ishant,
Sir, yes, sir.
can you find out anything out of this?
Yes, sir. Sir, I can
Okay,
find
so if
out
you can,
that first one, average velocity and velocity, sir.
okay, so find it out.
Yes.
Start finding.
Okay. Sir, that's it, sir. Question.
Yes, that's the question.
Okay.
Yeah, so are you able to obtain the first one?
Yes, sir.
Okay, so Ishant,
Yes.
shall I tell you the answer?
Yes, sir. I'm doing, sir. Sir, so first one I'm getting x equals to 1, sir.
Okay, so first one in the initial one you are getting, if you put x t equals to 0, so you are getting x equals to 1.
Yes, sir.
Okay. If you put t equals to 4, so you will be getting x equals to
Minus
1 plus,
199, sir.
how much you are getting?
Minus 199.
Minus 199. Okay,
Yes, sir.
so let's take it to be minus 199. So I get x at t equals to 4 is minus 1. So I assume it's correct. Okay, so you get
Yes,
this as minus 199.
yes, sir.
So how do you get minus 190? Just check it once more.
Yes, sir. Sir, because it's
I
9
get
plus
x
14.
equals to 1 plus 2 multiply 4 plus 3 multiply 4 squared, that's 16, minus 4 multiply 4 cube, that is 64.
Yes, sir.
So this you
So
get 1 plus 8 plus 48 minus,
256, sir.
okay,
256.
256.
Yes, sir. So that is
Okay, okay,
9 plus 48 minus 256. That equals
okay,
minus 199, sir.
okay. So,
Yes.
okay, that's correct. So you get minus 199. Fine. Then average velocity.
Yes, sir. I'm doing.
So you can obtain average velocity, total displacement by total time. And
Hmm.
total displacement will be final position minus initial position. So that
Yes.
will be negative 199 minus 1 divided by 4. So it's negative 200 by 4, which is negative 50 meter per second. Got it?
Yes, sir.
Okay, then try out this part 3, 4, and 5. Okay.
Yes, sir.
Okay, we'll meet again in next class. Bye, Ishan. Meet again
Sir,
on Saturday. Yes.
sir, can you say me those acceleration?
Which one?
Acceleration, sir, at equal to 1 and 2 seconds.
Isolation mean?
And no, sir.
Hmm.
Acceleration, sir. Can you
Okay,
see me?
okay, answer. See,
Yes, sir.
answer for this one.
Yes.
I'm just writing you the expression for velocity. Okay. So for
Okay, sir.
this one, you'll be getting the expression for velocity as 2 plus 6t minus 12t squared. Okay. Then
Okay.
expression for acceleration would be a would be equal to 6 minus 24t. Got it?
Okay.
Okay.
Yes, sir.
Okay. Bye.
Sir,
Yes.
sir, will you share me this, sir, in group? I'll do, sir.
Yeah, I'm sharing it. Just I'm sharing it.
Okay, sir.
Okay. Bye.
Thank you, sir. Bye, sir.